All right, geometry, I'm home with a sick kiddo, but I'm going to go through lesson 6-4 with you. And I'm going to do it a little bit kind of backwards, I guess, a little bit. This is inequalities in one triangle. There is kind of two main concepts in this section. The first one that they talk about, like example 1, is a little bit harder to understand. So I'm going to do example 2, 3, and 4 with you, which are very easy. And then we're going to backtrack to example 1. So just a little bit backwards, so hopefully you can kind of follow what I'm doing here. This first page has a lot of like vocabulary in it. So like this first one is just comparison property, basically saying that I'm allowed to compare things with an inequality, like less than, greater than. And specifically what we're going to be doing is we're going to be talking about a triangle, and we're comparing like angles versus sides, okay? So like one of the concepts, which is the easier of the two, which we're going to start with, says like, let's say this angle is, I don't know, 50 degrees, and this angle is 70 degrees, and this angle is 60 degrees. For one thing, they all have to add up to be 180, so that does. But the way that this works is like when we're comparing these angles, we would say that like angle B is, and this is where it gets confusing, greater than, angle B is greater than angle C, which is greater than angle A. Like if I go in order of like measure, okay? So these are my inequality symbols. These are just like my angle measures, but it's saying that like the value of B is bigger than the value of C, which is bigger than the value of A, going in order. Or you could flip these around and say angle A is less than angle B, which is less than angle angle A is less than angle C, which is less than angle B. I can go like that instead. Now, when we switch that around and we start talking about the sides, the thing that you want to do is that like this 70-degree angle is the biggest one. And what he is doing is these two sides are opening up to make this third side. So what I want to do is I want to look at the side opposite the biggest angle, 70 degrees. His side is AC, okay? So if 70 degrees is the biggest angle, then AC has to be the biggest side, okay? The middle side is going to be the one that's opposite the middle angle. So if 60 degrees is the medium-sized angle, then AB will be my middle side. So that's going to be the second longest side. And then I flip that around, and the smallest side is going to be the one opposite the smallest angle, okay? And the reason for that is because, like, it's not opening up as wide. Like, this is the width that 50-degree angle is opening. And so this opening is going to be less than, like, this opening would be, okay? So BC would be my smallest side, okay? And again, you could flip that around and say BC less than AB less than AC, okay? Like that instead, okay? All right, so I'm going to go and do, and some of these other properties that we have here, I'm going to talk through those as we go through them. And so, but that's just the main thing, is that we are going to be comparing angles and sides to each other in a triangle, okay? All right, so let's go down to example 2, and then we'll backtrack, all right? So here we want to order the triangle measures, and we want to list the angles of this triangle in order from smallest to largest, okay? Smallest to largest, keep that in mind, smallest to largest, okay? They gave us the measure of each side. So, so this side is 5.4. Gosh dang it. I imported these as pictures because they didn't show up very well on my page, and now they're wanting to do all crazy things. Okay, so this is my smallest side, which means that my smallest angle will be the one that's opposite that, okay? So if we're going smallest to largest, we would say L is my smallest one, okay? Then if I go my middle one, 6.1 is the next up from there. That means angle N is going to be my medium-sized angle, okay? So I'm going to say angle L is less than N, which is less than my biggest angle is opposite 9.5, so M is the largest, okay? And I put these inequality symbols showing that this is small, this is the medium-sized one, and this one's the largest one, okay? So in that order, that's how it goes, okay? Small, medium, large. There it is. All right. Hopefully that's making a little bit of sense. This one is asking me to order the sides from shortest to longest, okay? So here, they don't give me all the information quite yet. I know that this is a 51-degree angle. I'm going to write that this is 90 because that has a box in the corner. But then we need to figure out what this angle is, okay? And so we can do that by adding them up and subtracting from 180. But if this guy is already 90, then these two should add up to be the other 90, right? Like if we're taking shortcuts. So really I could just do 90 minus 51, and that's going to be like 39, I think, 39 degrees, okay? Now, again, we're going the sides in order from shortest to longest, okay? So I'm going to look at the angle that's the shortest. 39 is the smallest. So if I go opposite from him, his side, the side opposite, that's going to be the shortest is WY. WY is the shortest side, okay? So short, medium, long. The medium side is the one opposite the 51 because that's the next one order. So YX, if you call it XY, that's totally fine. The one opposite the 90-degree angle is the longest side. It's like the hypotenuse, right? Like this is a right triangle. The hypotenuse is going to be the longest. That is WX. So if I'm going small, medium, large, I'm going to put my inequalities this way to show that this guy is less than this guy, which is less than this guy, okay? So that's how they want me to write it. So hopefully that was like fairly short and sweet. That was example 2 and 3. Example 4 is a story problem, which is asking kind of a similar concept. They are saying during a game of paintball, opposing teams try to eliminate players on the opposite team. Manny is here and Lynn is here. They are on the same team and want to eliminate Logan. Okay, from the game, if Manny, Lynn, and Logan are all located at the positions shown on the diagram, who is closer to Logan? Okay, so we want to say is basically this distance or this distance smaller. Which one is the shorter distance? Who is closer? Okay, so what I need to do is I need to look at, if I'm trying to look for this distance, I'm going to look at this angle in comparison to this angle. It's kind of like that crisscross method that we did with the isosceles triangles, right? So I'm comparing this angle to this one, but we don't know this angle. So I have to find it, add those two together. 39 and 76. Oh, goodness. Goodness. We got a little cough. 39 and 76 is 115 degrees if I add this together. If I subtract that from 180, I get 65 degrees. So 65 is here. So I'm looking for, again, the shortest distance. Who is closest to Logan? All right. Since 65 is smaller, that means this length right here is smaller. So Lynn is going to be closest to Logan because the angle is smaller. Okay. So again, that kind of like if you think of this as like a mouth, like a chompy thing in Pac-Man, right? Do you guys know what Pac-Man is? I don't know. Are we too young for that? Here's my chompy mouth. So here's my Pac-Man guy. My chompy mouth. 65 degrees is how much he's opening. So his little teeth over here are only opening 65 degrees, right? Versus if I do my Pac-Man this direction, okay? If here is the mouth, here's my little Pac-Man. Here's where his teeth are. He's opening up 76 degrees. So this distance is going to be larger because he's opening up wider. I don't know if that helps you at all, but that's like how you can think of it, okay? So Lynn is going to be closest to Logan because he is only 65 degrees. Blah, blah, blah. Lynn is the answer to that one, okay? All right, last concept that's a little bit harder. Buckle in, take a deep breath. Here we go. Okay, there's a lot of stuff going on in this diagram. Holy crap. Okay. Here we have, let's see what we have going on here. We have this triangle right here. Woo. We have that triangle right there. And then we also have another triangle right here. Okay. Now, angle 1 is what's called an exterior angle for this big overall triangle, okay? Now, here's the deal. I'm going to do a little side note over here, and let's just talk through, getting rid of all the other stuff. Let's say this is angle 1, this is angle 2, this is angle 3, this is angle 4, okay? if angle 3 is, I don't know, 60 degrees, angle 4 is 50 degrees, angle 2 is 70 degrees, okay? Those all add together, right? Angle 1, since he is an exterior angle and he lives on a straight line with angle 2, he will be 110 degrees, right? Angle 1 and angle 2 add together to be 180, okay? Now, we've talked about this before, how angle 1, he is 110 degrees. That is exactly the same as adding these two angles together, right? 3 and 4. So angle 1 is equal to angle 3 plus angle 4. Like, that's the way that it works. These two angles that he doesn't touch. He's touching angle 2. So we cross off angle 2. He is equal to angle 3 plus angle 4. Now, here's the deal. If 3 and 4 have to add together to make what angle 1 is, then that means angle 1 by itself is bigger than angle 3, right? Like if this is 110 degrees and these two have to add together to make up 110, then that means angle 3 has to be smaller than 110, right? Because it needs angle 4 to add to him to get how big angle 1 is. So angle 1 is the biggest angle and angle 3 is a smaller one. In addition to that, angle 1 is also going to be bigger in size than angle 4 because 4 has to have a partner to go with in order to be as big as angle 1, right? So what we can do is we can say that, hey, angle 1 has to be bigger than angle 3 and angle 4, okay? So that's kind of how that works, all right, with exterior angles. So let's talk through this and let's see what they're asking. List the angles that satisfy the condition. They want which angles are less than the measure of angle 1. Okay, so what angles are smaller than angle 1? So this kind of just goes on what we just talked about. Angle 1 is this exterior angle. So I'm going to look at this overall big triangle, okay? Angle 1 is this guy here. So in my diagram over here, I said that this angle right here plus this angle right here has to add up to be angle 1. But the problem is, this angle up top here is these two together. And this angle down here is these two together, right? So in other words, angle 1, whoop, let me zoom in. Angle 1, gosh dang it. This picture isn't, okay, all right. What are you doing? What are you doing? Okay, let's try this again. Angle 1 is equal to these two things added together. But since these two things are each made up of those two, it's like 3 plus 4 plus 6 plus 5. These 4 angles together make up the same size of what angle 1 is. It's like these two are adding together to be the 70. These two are adding together to be the 60. These two are adding together to be the 50. This is my 70-degree angle. This is my 110, right? These two make the 60, these two make the 50, and all together it's 110. So if all 4 of these angles are required to be added together in order to be as big as angle 1 is, that means all of those individually, like if I take 3 by itself, angle 3 has to be smaller than angle 1. Angle 4 has to be smaller than angle 1. Angle 6 would have to be smaller than angle 1. Angle 5 would have to be smaller than angle 1, right? So if I want to know the measures of the angles that are smaller than angle 1, it would be 3 and 4 and 6 and 5. Those angles all have to be smaller than angle 1, okay? Because those are my interior angles that add up to be that exterior angle, okay? Now let's go down into part B, and they want to know which angles have to be bigger. Yeah, 3, 4, 5, 6. Okay, they want to know what measures of the angles have to be greater than angle 8. Okay, so I'm going to go and find angle 8. Let me get rid of all this stuff. Okay, angle 8 is this guy right here. Okay, now here's the deal. Angle 8 is an interior angle. He's inside of this big triangle right here. Okay, now angle 8 is touching angle 1, and it does look like angle 1 is bigger than angle 8, but you can't go off of the one that's next to him. We need to look at the interior angle versus the exterior angle that's not touching angle 8, okay? So the only other exterior angle that we have here is angle 2, okay? And things I know about angle 2. Angle 2, the two angles that would add up to be angle 2 would be this guy here and this guy here. The one that he's not touching, right? He's touching angle 3 and angle 4. In order to be angle 2, we would have to take this angle here and this angle here, which is really 8 plus, and since 6 and 5 are going together, these two angles added together, or 3 angles added together, would be the measure of angle 2, okay? So that means that angle 2 by itself would have to be bigger than angle 8 by itself, right? These 3 added together are equal to this one, so that means 8 has to be smaller than angle 2 by itself, okay? So down here, measures of angles that are bigger than angle 8 would be the measure of angle 2, because that is my exterior angle. Yes, I understand that angle 1 is next to angle 8, and it looks like it's bigger, but because of the exterior angle theorem, exterior angle theorem is the one that says that this angle is equal to this one plus this one. Because of that, that's how we know that those angles have to be bigger, okay, and smaller. All right, so that was a little bit harder of a concept. That's going to be like the first 3 problems on the homework. So do your best with those. A little bit harder, but then the other concept is fairly easy. So homework, let's see, homework. It's a little bit longer, but some of these are real quick. So these problems, page 377, 1, 2, 4, 6 through 11. Actually, you know what? Let's do just 6, 8, 10. How about that? I'll cut it down. 6, 8, 10 instead of 6 through 11 all. We'll cut those 3 problems down. 6, 8, 10. And then 22, 24, and then 28 through 34 evens. Okay, so it's a little bit less. It might be like 10 problems or so. Okay, so there you go. Get those all written down. If you need to pause, go for it to get those written down. I should be back tomorrow, so yeah, there we go.